Welcome back to the Deep Dive, everybody. Today we're diving into a concept that's honestly a bit of a head-scratcher, even for those of us who, spend our days wrestling with philosophical puzzles. We're talking about relations.
Yeah, relations.
It might sound kind of abstract at first, but trust me, it gets right to the heart of how we understand, pretty much everything. How we break down reality. How we see the connections between, from the smallest things to these huge systems that we're all a part of.
It's true. And to guide us through this dense philosophical jungle, we're going to be focusing on let's call it a treasure map. We're going to be looking closely at the relations entry in the Stanford Encyclopedia of Philosophy. It's a deep, deep well of knowledge, and we're going to distill it for you so you don't have to wade through all those pages. Think of it as, like a philosophical cheat sheet.
Exactly. So what are we setting out to do in this deep dive?
Yeah.
Well, first off, we want to pin down exactly what philosophers mean when they use the word relation. Like, what is it really? How is it different from just talking about the properties of things?
Right.
And then we're going to get into some pretty heated debates. I mean, there are some serious philosophical battles over whether relations actually exist, what they're like if they do exist, and what role they play in our understanding of everything. And by the end of this, you, my fellow philosopher, will have an even more powerful set of tools to really analyze arguments, dissect the very fabric of how things are connected, and just see the world with a new clarity.
Absolutely.
So let's jump right in, shall we? Let's start with the absolute basics. Like, how do we even tell the difference between a property and a relation?
Right. Well, the Stanford Encyclopedia entry, it lays out this really basic distinction. It says that properties are monadic, which means they apply to just one thing. Like think about a cat being furry. That's a property of that specific cat, but a relation.
Yeah.
That's polyadic.
Polyadic. Okay.
It involves connections between two or more things. So like the cat is on the mat. That right there, that's a dyadic relation.
It is.
Because it's talking about both the cat and the mat together.
Makes sense. So the cat's furriness, that's just about the cat. But being on the mat, that automatically brings the mat into the picture, too. You need both of them for that to make sense.
Exactly.
It seems pretty straightforward when you put it like that. But the entry, it actually points out that defining the difference between properties and relations without already assuming you know what they are.
Yeah.
It's way harder than you might think.
It really is.
It's like imagine trying to explain what existence is without ever using the word exist.
Yeah, you're right. It's tricky because it's so basic, right? The language we're using, it kind of already has these concepts built into it.
Right.
But the entry does give us some helpful ways to wrap our heads around it. One way is to think of relations as something that one thing bears towards other things. Like there's this directionality involved.
Okay, so it's not just about how many things are involved.
Right. It's not just about the numbers.
Because at first you might think, okay, properties are about one thing, relations are about more than one thing. But the entry brings up those pesky reflexive relations, like identity.
Ah, yes, identity.
A is identical to A. That's a relation, right?
It is.
It's just a relation that loops back on itself. So it's more about this idea of moving from one thing to another, even if sometimes those two things are actually the same thing.
Exactly. That's a crucial point.
Okay, so we've got this basic difference down, right? Now, where do philosophers stand on all this? Do they all agree that properties and relations are like legitimate parts of reality?
Well, philosophers being philosophers, there's a whole spectrum of views. Mm-hmm. The entry maps out four main positions, and it's a bit like, a philosophical compass.
Okay, I like that, a philosophical compass.
So first, you've got the hardcore nominalists. They're skeptical of both properties and relations. They worry that these concepts, they kind of commit us to these universal things, these abstract entities that are out there floating around in the world. And they're not so sure about that.
Right. They're like, hold on, let's not get too abstract here. What about the philosophers who are okay with properties, but they get a bit squeamish about relations? What's going on there?
So often these philosophers, they're working from a specific metaphysical perspective, maybe one where properties are seen as more fundamental, like they're built into the essence of things. Relations in this view might seem a little more out there, harder to explain.
Right, like a little too spooky for them.
Right, exactly. And then you've got the opposite camp. The philosophers who think relations are absolutely essential for understanding how everything's connected, but they're not so convinced about properties existing on their own.
Oh, that's interesting. So they're prioritizing connections and structure.
Exactly. And then, of course, there are the realists, the ones who embrace both properties and relations, saying, look, we need both of these building blocks to understand the world.
Makes sense. So it's all about figuring out which of these fundamental ingredients are really necessary, which ones are justified for building a coherent picture of reality.
That's the core of the debate.
All right, so we've got the lay of the land, the philosophical compass, as you called it. Now, let's dig deeper into relations themselves. The entry goes into a bunch of important distinctions within the category of relations, like there's this thing called adicity.
Yes, adicity.
Or degree or arity.
It's all the same thing.
Okay, good to know.
And it's really just about the number of participants in a relation. So, like we talked about monadic, that's for properties, right?
Yeah.
And dyadic, that's like adjacent to. But then you can have triadic relations.
Triadic, like a tricycle.
Right, like between, that involves three things. And then, of course, you can have relations with 4, 5, any number of participants. That's what we call an adic.
So like gives would be a triadic relation. You've got the giver, the receiver, and the gift. Okay, that makes sense.
Exactly.
And then there's this concept of relational properties. This sounds like it's bridging the gap between properties and relations.
It is. It's a sort of hybrid. So remember, a relation, that's a connection between things, but a relational property, that's something an individual thing has because of its relation to something else.
Okay, I think I'm following.
So let's say Antony is married to Cleopatra.
Right.
The relation there, the connection, is marriage. It's dyadic between two people. But then being married to Cleopatra, that becomes a property of Antony.
So it's like the relation is the shared connection, and the relational property it's like that individual side of the connection.
You got it.
Okay, that's pretty neat. Now, what about this unigrade versus multigrade thing? That seems to be about whether the number of things involved in a relation is always fixed?
Precisely. With a unigrade relation, the number of participants is always the same. Like, it's always binary or always ternary and so on. But then you have multigrade relations. They can change, The number of participants can vary.
Like what?
Well, the entry suggests causation might be an example. Sometimes you might have a single event that causes another event. But in other cases, you might need a whole bunch of different causes working together to produce an effect.
Right.
And the same thing could happen with logical entailment. Sometimes one premise leads to a conclusion. Sometimes you need a whole set of premises.
I see. So it's like the number of things involved is kind of flexible with these multi-grade relations. And I bet that throws a wrench into logical analysis, right? I mean, trying to keep track of all that shifting around.
It does. And that's why there's this whole debate about whether these multigrade relations are really a distinct kind of relation.
Makes sense.
Some philosophers, like Armstrong and Dixon, they're not so sure. They think these cases can be understood as just, regular fixed diarity relations, but with some extra bells and whistles, like sets or other structures. But then you have philosophers like Morton, Fine, McBride, and Hossack. They're like, no, these multigrade relations are real. They're genuinely different.
So there's still some philosophical wrestling going on there.
There is.
All right, let's move on to symmetry. At least with binary relations, symmetry seems like a pretty easy concept to grasp.
It is. It's basically about whether you can swap the places of the things in the relation and still have the same relation hold. So, like, being a sibling of, that's a classic symmetric relation. If X is a sibling of Y, then Y is automatically a sibling of X.
Makes sense.
But then you have non-symmetric relation. Like, think about loving. If X loves Y, it doesn't mean Y has to love X back.
Sadly, no.
And then asymmetric relations, that's a specific kind of non-symmetric relation. With asymmetric relations, if X bears the relation to Y, then Y can never bear that same relation back to X, like being a proper ancestor of.
Okay, so all asymmetric relations are non-symmetric, but not all non-symmetric relations are asymmetric.
Exactly. Loving can be reciprocal sometimes, but it doesn't have to be.
Right. But the entry actually mentions a debate about whether non-symmetric and asymmetric relations are, like, even necessary. Some philosophers think we might not need them at all.
It's a bold claim, for sure.
It is.
Russell, for example, he thought they were absolutely essential. He needed them to explain order and structure in the world. But more recent philosophers, like Armstrong, Dorr, and Simons, they've been exploring whether we could reduce them to just symmetric relations, maybe by adding in some extra entities or conceptual tools. But then you have McBride pushing back, arguing against these attempts at reduction.
So what is it about these non-symmetric relations that makes some philosophers want to get rid of them? What's the big problem?
Well, the entry points out that they seem to introduce this order, this directionality between the things in the relation. There's this differential application.
Okay, meaning good.
Meaning that the way the loves relation applies when Alice loves Bob is different from when Bob loves Alice. There's a direction there. You can't just swap them around.
Right. It's like the relation is pointing in a specific direction.
Exactly. And that's not the case with symmetric relations, like being the same age. It doesn't matter if you say Alice is the same age as Bob or Bob is the same age as Alice. It means the same thing.
I see. So with non-symmetric relations, it's like there's a specific way the relation connects the things, and then the entry talks about attempts to formalize relations using like ordered pairs, triples, and so on. It seems like a natural move, trying to use math to understand them.
It is. It's very common in formal semantics and metaphysics. The idea is to represent an adic relation as a set of ordered n-tuples. The ordering is supposed to capture the non-symmetry.
Makes sense. But apparently this approach runs into some pretty serious problems.
It does. And as a philosopher, you need to be aware of these.
So what are the issues? I mean, using the mathematical idea of order to explain order in relations, that seems pretty intuitive.
Right, but the first problem is circularity. You see, the very definition of an ordered sequence, whether it's a pair, a triple, whatever, it already assumes you know what order is. You have to know what first and second and so on mean. So using ordered sequences to then explain the order in non-symmetric relations is like, well, it's like using a dictionary to define a word by using that same word in the definition.
So it's like you're already assuming the thing you're trying to explain.
Exactly. And then there's this other problem. This approach tries to explain a relation between things by making it into a property of a single thing, the ordered tuple.
Oh, I see.
So instead of talking about the taller than a relation between two people, you're talking about a property of the ordered pair containing those two people. It kind of shifts the focus away from the connection itself.
Right. It's like trying to explain a hug by describing the two people hugging as just one big combined object.
Yeah.
It misses something important.
Exactly. And then there's the whole issue with the Kuratowski definition of ordered pairs in set theory.
Oh, yeah. Kuratowski.
So Kuratowski found this clever way to define ordered pairs using only sets. But the thing is, there are infinitely many other ways you could do that. Why pick Kuratowski's way? It seems kind of arbitrary.
Yeah.
And more importantly, even Kuratowski's definition, it still seems to sneak in the idea of order. To understand his definition, you already need to know that the first element in the pair is the one that's in a set by itself.
Right. You need to know which element is playing which role.
Exactly. So these attempts to reduce relations to ordered sequences, they end up stumbling over the very thing they're trying to explain.
Okay, so that's a dead end. What about converse relations? They seem pretty tied up with this whole directionality thing.
They are. So for any binary relation, you can have a converse relation. It's basically the relation flipped around, like before and after, above and below. Those are classic examples.
So if event A is before event B, then event B has to be after event A.
Exactly. They're like two sides of the same coin. You can't have one without the other.
Right.
Here's the thing. For non-symmetric relations, the relation and its converse, they're different.
Different how?
Well, think about loving again. Alice can love Bob without Bob loving Alice back. So Alice loves Bob is a different state of affairs from Bob loves Alice, even though they're both about love.
Okay, that makes sense.
And the entry points out this interesting fact. As you add more things to the relation, as the arity goes up, the number of possible converses explodes.
Yeah,
it gets really big really fast. Like a quaternary relation, a relation with 4 things, it can have 23 different converses.
Wow, that's a lot of flipping around.
It is. It just shows you how complicated things get when you start thinking about order and direction in relations.
Okay, so we've covered some pretty fundamental ground here. Defining and categorizing relations. Now, let's get to a really central distinction. Internal versus external relations. This seems like it's key to understanding how relations fit into the world.
Absolutely. It's all about whether a relation between things is determined by the nature of those things themselves, or whether it's something, something more external, something that depends on other factors.
Right.
But here's the thing, and any good philosopher should know this. There isn't one universally agreed upon way to make this distinction.
Oh, so it's a bit of a philosophical minefield?
You could say that. So let's start with Moore. What's his take on internal relations?
Let's hear it.
For Moore, A relation is internal if it has to hold between the things it relates whenever those things exist. It's like if it's possible for those things to exist without the relation holding, then the relation is external.
Okay, so it's about whether the relation is, like, absolutely necessary.
Exactly. Like, think about biological origin. If your identity is fundamentally tied to your biological parents, then the relation originates from might be internal in Moore's sense, because you can't exist without having originated from those parents.
Makes sense. So Moore's criterion is all about the modal status of the relation. Like if it holds, it must hold. Then we have Armstrong, who shifts the focus to the intrinsic properties of the things being related.
Right. For Armstrong, a relation is internal if it's completely determined by the non-relational properties of the things themselves, considered individually. So if the relation depends on anything else, anything outside of those intrinsic properties, it's external.
Okay, so example.
Sure, having the same shape as. That seems like an internal relation for Armstrong. If object A is a cube and object B is also a cube, then them having the same shape is entirely determined by their individual properties of being cubes.
Right, right.
But then think about spatial relations, like being 3 meters apart. That's external for Armstrong, because knowing the individual properties of two objects doesn't tell you how far apart they are.
True, true. Like knowing that one thing is a cat and the other is a tree doesn't tell you anything about their distance. Okay, and then we have Lewis, who brings in this concept of supervenience.
Right. Lewis gets a bit more nuanced. He says a relation is internal if it supervenes on the intrinsic natures of the things it relates, taken separately. What that means is if you have two pairs of things and they're exactly alike in all their intrinsic properties, then they have to have the same internal relations.
Okay, so it's like if the things are the same, the internal relations can't be different.
Exactly. And then for Lewis, external relations are the ones that don't supervene in this way. They depend on more than just the intrinsic properties of the things individually, but they do supervene on the intrinsic nature of the whole system.
Can you give an example?
Sure. So having the same shape as, that's still internal for Lewis. If X has the same shape as Y and W doesn't have the same shape as Z, then there has to be some difference in intrinsic nature somewhere, either between X and W or between Y and Z.
Makes sense.
But now consider being 3 meters apart. Lewis says that's external. You could have two identical objects that are 3 meters apart or 10 meters apart without any change in their individual intrinsic properties.
Right, they're being 3 meters apart, and this doesn't come from just them.
Exactly. But the fact that they're 3 meters apart does depend on the whole system, like the two objects and the space between them. If you made an exact copy of that system, the copies would also be 3 meters apart.
So, same shape is determined by the internal stuff, but distance requires looking at the whole system. But as the entry points out, these different definitions, they don't always agree.
That's really important to keep in mind. You could have a relation that's internal according to one definition, but external according to another. Like having the same shape as, that wouldn't be internal in Moore's sense.
Oh, it's not.
Because, object X could exist as a sphere and object Y could exist as a cube. Their mere existence doesn't force them to have the same shape.
Oh, right. It's possible for them to exist and have different shapes.
Exactly.
Okay, so this just shows how careful we have to be when we're talking about internal and external relations. We need to be really precise. Okay, let's move on to something even more meta. The conditions for the existence and identity of relations themselves. Like, what does it even mean for a relation to exist, and when are two relations the same?
Now we're getting into some really deep metaphysical waters. So first, you have this distinction between abundant and sparse conceptions of relations.
Yeah, abundant and sparse. Go on.
The abundant view, it basically says that for any collection of things, no matter how random, there's a relation that holds between them. If you can come up with a predicate, a way of describing those things together, then boom, there's a corresponding relation in the world.
So even if the relation is totally nonsensical, like being a funnier philosopher than us, there's a relation for that, for every pair of philosophers.
Exactly, even if the comparison is absurd. But then you have the sparse view.
Yeah.
That's way more restrictive. It says, hold on, let's only accept the relations that are actually needed to explain real similarities and differences in the world.
Makes sense. So a sparse theorist would probably reject that funnier philosopher relation unless it actually explains something about the world.
Right. And this ties into the next distinction. A posteriori versus a priori views on existence. So Armstrong, he's got a posterior view. He says relations only exist if they're actually instantiated, if they're out there in the world, and we figure that out through experience.
Okay, so like the existence of space and time, that's something we discover through physics.
Exactly, but then you have philosophers like Zalta and Williamson. They've got more a priori views. They think logic alone can guarantee the existence of certain relations, even if we never actually observe them.
Interesting. So they're saying some relations just have to exist because of the way logic works.
That's the idea. And then, of course, you have intermediate positions. Some philosophers might say, okay, some relations might exist even if they're not instantiated, like relative velocities in physics. Maybe no objects actually have those velocities, but the relations still make sense theoretically.
Right, right. So there's a whole spectrum of views on how many relations there are and how they come to be. But then there's this other question, and this one seems even trickier.
What's that?
When are two relations considered the same relation?
Ah, yes. The problem of identity for relations. It's a really deep philosophical question. So one approach is to say that two relations are the same if they're necessarily equivalent, meaning they hold between the exact same sets of things in every possible world. It's like no matter how the universe could be, those relations always pick out the same connections.
Okay, that's a pretty strong requirement.
It is. But some philosophers want an even stricter criterion. They say, no, two relations are only the same if they have the same analysis, if you can break them down into the same simpler, more fundamental relations.
Oh, so it's like you need to be able to show that they're made of the same stuff.
Right. And then you have other approaches. Some focus on causal powers. They say two relations are the same if they have the same effects on the things they relate. And then there's Zalta with his theory of abstract objects.
Zolta always brings in the abstract objects.
He does. So for him, relations are the same if they encode the same abstract object, where abstract objects are these things that capture all the properties they exemplify.
So no easy answer to this identity question.
No easy answer. And as the entry points out, the right way to think about identity might even depend on what you're trying to do, what your philosophical goals are.
Right, right. So we've done a lot of defining and categorizing. Now let's get to the challenges, the things that make relations so philosophically problematic. The first one is, well, it's kind of a basic one. Where are they?
Ah, yes. The problem of locating relations is a classic one, famously brought up by McTaggart.
McTaggart, the master of philosophical puzzles.
So he asks, if Glasgow is west of Edinburgh, a simple relational fact, where is this being west of relation? It doesn't seem to be in Glasgow, not in Edinburgh, not even in space between them.
Right, it's not like a physical object that you can point to.
Exactly. And that can be really unsettling for philosophers who think that to exist is to be locatable, to be somewhere in space.
So how do philosophers who believe in relations deal with this?
Well, some say relations just exist in a different way than physical objects, so they don't need to be located in the same way. Others say they're abstract entities existing outside of space and time, like Russell suggested. And then there's Lewis. He's like, look, if relations are really useful for explaining things, maybe we need to rethink our whole idea of what it means to exist.
So maybe our intuition that things have to be somewhere is just wrong.
Maybe.
Okay, what's the next challenge?
This one is about how relations are characterized. Some philosophers, like Heil and Lowe, they say relations don't fit into our traditional categories. They're not substances, they're not attributes, they're kind of in between.
Right, neither fish nor fowl.
Exactly. And that makes some philosophers uncomfortable. But the entry pushes back on this, saying, maybe our categories are just too limited. Maybe relations are just a fundamental category in their own right.
Makes sense. And then there's the argument that relations are problematic because they depend on the things they relate.
Right, but the entry counters that by saying, hey, properties are dependent too. A property can't exist without something having that property.
True. So dependence alone doesn't rule out relations. Okay, let's tackle the big one. Bradley's regress. This was notorious.
It is. It's a really influential argument against external relations. So Bradley, he sets up this dilemma. He says, either a relation is nothing to the things it relates, in which case it can't really relate them, or it's something in its own right, in which case it needs another relation to connect it to the things.
Okay, I see where this is going.
Right, and that leads to an infinite regress. You need an infinite chain of relations just to have one relation hold. Bradley's conclusion was, this whole thing is absurd, so external relations can't exist.
So how do philosophers get out of this mess? The entry talks about appealing to facts and tropes.
Right. The general idea is to say, okay, the relation is something over and above the things it relates, but it doesn't need another relation to do the relating. It just does it.
Okay, so how does that work with facts?
Philosophers like Hockenberg, Armstrong, and Hossack, they say the fact that a relation holds, that's enough. Like that's all you need. The fact itself can't exist unless the relation holds, so there's no need for another relation to bridge the gap.
Makes sense.
But then McBride comes in and he's like, wait a minute, what is a fact if not a structured entity where things are related? So using facts to solve the problem might be circular.
Ah, right.
Yeah.
You're still assuming things can be related without another relation.
Exactly. And then you have the trope approach.
Yeah.
Proponents of relational tropes, like Marin and Simons, they say relations are these particular things, tropes, tied to specific individuals. So a relational trope between A and B that's a unique entity that can't exist between any other things.
Yeah.
And because it's specific to A and B, its very existence constitutes them being related.
Okay, so the trope itself does the relating.
Right. But McBride again points out the problem. How does the trope itself relate A and B? Just saying it exists doesn't explain how it does the relating.
So both approaches seem to stumble over this idea of how the relating actually happens.
They do, and that's where this other idea comes in, the idea that maybe the bearing of a relation isn't itself a relation.
Okay, unpack that for me.
So the argument is that the regress, it comes from this mistake, this idea that relating is a kind of relation that needs another relation to connect it. But if we get rid of that assumption, the regress disappears.
I see.
Philosophers like Armstrong, Grossman, and Lewis, they've all argued that the instantiation of a relation is just a basic fact. It doesn't need any further explanation.
Okay, so it's like things just are related and that's that.
Basically. And then you have Russell. He kind of just dismisses Bradley's argument by pointing to science.
Russell and his love of science.
He says that modern science relies so heavily on external relations, especially in physics, that it's more likely that Bradley's argument is wrong than that science is wrong.
Makes sense. It's like if science works and science uses relations, then relations must be okay.
Right. But of course, just saying an argument is wrong doesn't tell you why it's wrong.
True. So we've talked about challenges to external relations. What about internal relations? Are they safe from these philosophical attacks?
Not quite. The next section of the entry is all about reductionism.
Reductionism.
Yeah, the idea that internal relations, even though they're determined by the nature of the things they relate, aren't really a separate part of reality. They can be reduced to just talk about the things themselves.
Okay, I think I'm following.
So, because internal relations are, by definition, fixed by the intrinsic properties of the things, some philosophers say they're not really adding anything new. We can just talk about the things and their properties, and that's enough.
Give me an example.
Sure. The entry uses the example of two mountains, Ben Vorlich and Ben Vane. The fact that Ben Vorlich is taller than Ben Vane, that's an internal relation. It's determined by their individual heights. And the reductionist argument is that everything you want to say about Ben Vorlich being taller than Ben Vane is already captured by the facts about their heights. We don't need to add this extra thing, this being taller than relation.
Okay, I see. It's like the heights themselves are doing all the work, but the entry does mention some counterarguments.
It does. For example, some philosophers point out that we seem to directly perceive relations, like proportions. If we can see them, they must be real, right?
Makes sense. It would be weird to say we're perceiving something that doesn't really exist.
Right. And then there's this really important distinction between truth-making and ontological commitment.
Okay, what's that about?